Hello everyone, so in this lecture we will study about the electric flux and Gauss law, and then we will see Gauss law की properties क्या क्या होते हैं and Gauss law को हम apply कहाँ कर सकते हैं. So let's start from the electric flux. So for electric flux we will first of all electric flux is denoted by phi and it is written like this. So for electric flux we'll draw uniform electric field lines like this. These are the parallel lines. Although parallel लग नहीं रहे हैं, but हमें parallel ही assume करना है. Now let's take a surface S1. This is the surface S1. And let's take another surface S2, which is like this. Now we can see number of electric field lines passing through the surface S1 is 1 and number of electric field lines passing through the surface 2 are 3 lines. Now if the flux passing through the surface 1 is phi 1 and the electric flux passing through the surface 2 is phi 2, then the relation between phi 2 and phi 1 will be phi 2 will be 3 times of the phi 1. So we can say flux passing through a surface flux passing through a surface is directly proportional to number of field lines passing through the surface. Now we will see कि electric flux किन quantities पर depend करता है. So first of all it depends on electric field. If the electric field is strong, then the density of electric field lines is higher, and if density is electric field lines is higher, then the number of electric field lines will be more. And if the electric field lines are more, then the electric field lines passing through the surface will be greater and electric flux will be greater. Now the second quantity on which the electric flux depend, it is area of the surface. If area of the surface is small, then the electric field lines passing through the surface will be less and the flux passing through the surface will also be less. So if the surface area is very large, then the number of electric field lines passing through that surface will be very large and the flux will also be very large. Number 3 on which electric flux depends is angle between electric field and surface. So if angle between the electric field and the surface decrease, then the electric field lines passed through the surface are very less. How? Suppose this is a surface S1 and electric fields, this surface is perpendicular to the screen, so we can draw like this. And electric field lines passing through this surface are like this. So between the surface and electric field lines angle is 90 degree. Now if we decrease this angle, now angle will be less than 90 degree and electric flux line passing through the surface will be less. So electric flux will also be small, right? So when the surface and electric field lines are perpendicular to each other, then the maximum flux will pass through the surface, that we have seen, right? So now we will derive a mathematical expression of electric flux, and that is electric flux equals to E into A into cos theta. Here is the electric field, A is the area of the surface, theta is the angle between electric field and area vector. Here theta is the angle between electric field and area vector, or we can write this like this, E dot A. So remember these formulas. And phi यानी कि flux is a scalar quantity. What is the unit of flux? Unit of flux will be, first unit of electric field, that is Newton per coulomb. So Newton meter square per coulomb will be the unit of flux, right? Now what is the area vector? So suppose this is a surface which is perpendicular to the screen, then the area vector will be perpendicular to this surface, and that will be in this screen. So that can be in this direction or in this direction also, and that will be denoted n cap. So if it is in this direction, we can take is minus n cap, and if it in this direction, then we can take n cap, right? Now this is for a surface which is not closed. So now for closed surface like sphere, we take unit vector in the direction of the outward normal. Like suppose this is a sphere, so unit vector will be like this, in this direction, outward direction. So if we writing the flux for a small surface which has area, suppose area is ds, then we can write flux equals to integration of the surface E dot ds, right? Now we will use this formula, or we can write, if area is dA, then we can write in E dot dA form. Now we will use this formula and solve some questions. So आपको क्या करना है, फॉर्मूले याद रखने हैं, फॉर्मूले बेस्ड जो क्वेश्चंस आते हैं वो आपको सोल्व करने आने चाहिए. So there is a question, if an electric field is given to be like this in vector form, what is the electric flux through a surface having an area vector? So what is the electric flux formula? That is E dot A. And दो वेक्टर्स के डॉट प्रोडक्ट के लिए हम क्या करते हैं, I कोफिशिएंट को मल्टीप्लाई करते हैं. So 5 into 1 plus then J कोफिशिएंट को 4 into 2 plus then K कोफिशिएंट 6 into 3. So इसको कैलकुलेट करेंगे तो we will find the value of flux and unit will be Newton meter square per coulomb. So this is very simple question based on the formula. If you remember this formula, then you can calculate easily this flux. Now another question, charge Q is placed at the center of a sphere of radius R Find the flux of the electric field through the surface of the sphere due to the enclosed charge. So there is a charge Q. It's placed at the center of a sphere of radius r. Right. Find the flux of the electric field through the surface of the sphere due to the enclosed charge. Now, electric flux is E dot A, or we can say electric flux is calculated like this for a surface E dot ds. Now if we take a small surface which area is ds, then electric field due to this will be perpendicular to this, and area vector is also in this direction. So this is the electric field and this is the area vector, right? So electric field will be K into charge Q upon R square and electric field, or we can say this, we can written like this also, E ds cos theta. Theta is the angle between the area vector and electric field. Here angle is 0 degree, so ds into cos 0 degree. So this can be written like this, kq upon r square integration of ds. Integration of ds is none but the area of this sphere, that is 4 pi r square. If you calculate this, then it will be 1 upon 4 pi epsilon naught. K can written be like this. This is q upon r square and this is 4 pi r square. If you simplify this, then it will become q upon epsilon naught. And we will see in Gauss law how the flux and how the flux passing through a surface, through a closed surface, is always q upon epsilon naught. So electric flux passing through this surface will be q upon epsilon naught. यहाँ मैंने इसका डेरिवेशन किया है, बट आपको नीड नहीं होगी जब आप गॉस लॉ स्टडी कर लेंगे. Now we will study about the Gauss law and इसके क्या applications हैं उनके बारे में देखेंगे. So what is Gauss law? Gauss law says the electric flux through a closed surface. Closed surface is 1 upon epsilon naught times of the charge enclosed by the surface. So we can say phi equals to q enclosed by the surface upon epsilon naught. Right? Suppose there is a surface, or we can say this equals to integration. This symbol is for closed surface. E dot ds. Right? Suppose there is a surface, there is a arbitrary surface like this, and there are some charges in this surface, q1, q2 minus q3, q4 minus q5, q6. Then, and there are some other charges near the surface which are q7 minus q8. So what will be the electric flux through this surface? So इसको calculate करना बहुत difficult है, because फर्स्ट ऑफ ऑल इलेक्ट्रिक फील्ड यूनिफॉर्म नॉन यूनिफॉर्म होगा ये हम डिटरमाइन नहीं कर सकते. देन सरफेस एक सिंपल सरफेस नहीं, एक आर्बिट्ररी सरफेस है, तो कैलकुलेट करना, डेरिवेशन करना बहुत डिफिकल्ट होगा. बट बाय गॉस लॉ इट इज वेरी सिंपल. phi equals to q enclosed, that means total charge inside the closed surface. So Q1 plus Q2 minus Q3 plus Q4 minus Q5 plus Q6 upon epsilon naught. We will not write the charges which are outside the surface. These charges will not be included in this Q enclosed. So this is the total flux through this closed surface. So by Gauss law it is very easy to write the flux. Now we will study some important points regarding this law. First is Gauss law is true for only closed surface, no matter what is its shape or its size. So Gauss law closed surface के लिए valid है and उस surface की क्या shape है and क्या size है उससे Gauss law पर कोई भी असर नहीं आएगा. Like suppose there is a surface like this. There is a cube. This is not cube actually. Suppose this is the cube. And the charge inside this cube is suppose Q1 and Q2. Right. There is another surface, sphere. So charge inside the sphere is Q1, Q2. Suppose there is an arbitrary surface. So charge inside this surface also Q1 and Q2. This is S1, this is S2, this is S3. So for S1, flux will be Q enclosed upon epsilon naught, that means Q1 plus Q2. Similarly for S2, flux is phi 2. This is also equal to Q1 plus Q2 upon epsilon naught. Similarly the surface 3, flux is phi 3. This is also Q enclosed, Q upon Q1 plus Q2 upon epsilon naught. These all three are same. Right. So the Gauss law doesn't depend on the closed surface shape and size. The next is the term in the Gauss law, phi equals to Q enclosed upon epsilon naught. This Q enclosed is include only the charges which are inside the surface, inside the closed surface. आउटसाइड द सरफेस जो भी चार्जेस होंगे वो हम क्यू इनक्लोज पे नहीं लिखते हैं, जो अभी आपने देखा भी होगा. राइट. सो दिस इज द सम ऑफ all charges inside the closed surface. Right. Now the electric field, this can be written like this, no? E dot ds. So in this equation, so the electric field, it is due to all charges. It is not like the electric field produced here is only the inside charges. It is due to all charges. Now the another point ki what is Gaussian surface? Gaussian surface is that surface which we choose for the Gauss law. And for choosing the Gaussian surface, we keep two things in mind. The surface should be like this. The electric field is perpendicular to the surface or the parallel the surface. Because of that, we can simplify our calculations easily. Phi equals to E dot ds, right? This can be written like this: Q enclosed upon epsilon naught. Or this expression E dot ds, we can write E ds cos theta, or we can write like this. So sorry, if E is uniform, then E can be taken outside, ds cos theta. Now if the surface and electric field are perpendicular, if the area vector and surface are perpendicular to each other, E is perpendicular to the area vector. Area vector is denoted by n cap, so we'll write here n cap. So E is perpendicular to n cap, then theta will be 90 degree and cos theta will be 0 degree. So this becomes 0. If E is the parallel to n cap, then theta will be 0 degree and the cos 0 is 1, and this expression will become E into integration of ds, and this is E is A into total area. So we choose the Gaussian surface like this, that electric field and the surface are perpendicular to each other over the parallel to each other, and if electric field is uniform, then it simplify, calculation will be simplified. Now the another point is we can choose any Gaussian surface, like we can choose cylindrical Gaussian surface, or we can choose the circular is not a closed surface, spherical closed surface. So we will choose Gaussian surface like this, that our calculation will be easy. Now the one question, we solve some questions based on the Gauss law. A point charge Q is placed at the center of a half sphere. So there is a half sphere and there is center. Q is placed here. Find out the electric flux passing through the surface. So in this question, what we will do? So we clearly can say this is not a closed surface. So what we will do? Assume a half sphere like this. So now this is a closed surface. Now we can write phi equals to Q upon epsilon naught, right? But this is for the sphere. So phi for the hemisphere will be half of this. This will be Q upon 2 epsilon naught, right? Because here electric field is uniform, that's why we can do simply half of this flux. Now the next question is, electric charges are distributed in a small volume. The flux of the electric field through a spherical surface of radius 10 cm surrounding the total charges 25 voltmeter. Voltmeter is also the unit of electric flux. What will be the flux over a concentric sphere of radius 20 cm? So what we are given, there is a 10 cm spherical surface and flux through this surface. Suppose this is the S1 surface. So flux, this surface is 25 voltmeter. That means there are some charges inside this surface. Now there is another surface which is 20 centimeter. And that surface is concentric, so this will be like this. Center of these two surfaces will be same. Now for surface 2 there are charges only here inside this surface. So flux passing through this surface will be the total charge inside this surface upon epsilon naught, and that is equal to phi 1. So answer will be same, 25 volt meter. Now next question, find the flux passing through a cube if charge q is placed first at the center of cube, second at the face of cube, and third at a corner of cube. So in this type questions what we will do, we will make a closed surface, right? So first at the center of cube, if the charge is placed at the center of cube, then simply by Gauss law flux will be q enclosed upon epsilon naught. Now the B part, when charge is placed at the face of cubes, then we will assume another cube. Now this is a closed surface and the flux will be q epsilon naught, q upon epsilon naught. So flux through these two cubes is q upon epsilon naught, but flux through the one cube, that is our desired flux, suppose this is phi 1, this will be phi by 2, right? So this will be a q upon 2 epsilon naught, because this q charge is set by 2 cubes. Now in the C part, charge q is at a corner of the cube. When charge is at a corner of the cube, then it will be set by 8 cubes, right? 4 cubes you can see here, and 4 cubes will be here also. Like then the q charge will be covered. Then we can say the charge q is placed in a closed surface. So the flux through this whole surface is q upon epsilon naught, but the charge q is placed at a corner of the cube, so flux from that cube will be q upon epsilon naught, and is 1/8 part, because the charge q is placed at a corner of the cube, so it will be q upon 8 epsilon naught, right? Now we understood कि जो आपका Gauss law है उसके क्या क्या properties है and how we apply this Gauss law. Although Gauss law का application mostly electric field find करने में होता है, and electric field, suppose आप electric field find कर रहे हो, suppose ये wire के लिए, wire this intensity, charge intensity is lambda, and if you want to find the electric flux through this surface, right? This is the infinite long wire. Then we will consider a closed surface for this wire. Suppose closed surface is, it is cylindrical. Why we have taken cylindrical? You will see. Electric field lines through this electric field lines due to this wire will be like this. If this is positively charged, now this cylinder has 3 surfaces, S1, S2 is the curved surface, and S3. If you write Gauss law equation, phi equals to q upon epsilon naught equals to integration of E dot ds, right? E will be the uniform here, so q upon epsilon naught, q will be the if length of this cylinder is L and radius is R, then Q will be lambda into L upon epsilon naught, and it will be E dot ds, that means E ds cos theta. E is uniform, so E will be outside the integration, it will be ds cos theta. Right. Now for surface S1 and for surface S3, the area vector will be in this direction, outside the surface, in this direction. If for S1 it is n cap, then for S3 it is minus n cap, right? And the electric field is in this direction or in this direction. So angle between this area vector and electric field is 90 degrees. So theta is 90 degree here. So lambda L for this surface, lambda L upon epsilon naught equals to, suppose this is E, this is E13. For surface 1 and 3 will denote by E13. ds is a smaller area, so ds into cos theta is cos 90 degree, this is 0. That means lambda L upon epsilon naught equals to E13 into 0. This cannot be 0, that means E13 is 0. So E13 is 0. For surface S1 and S3, electric field is 0. Right. Now for surface S2, suppose there is a point. That point is at distance x or say r, but in this case we will take radius capital R, right? So for this, area vector is in this direction and the electric field also in this direction, so theta will be 0 degree and this ds cos theta will be ds only. So this equation will become lambda L upon epsilon naught equals to E into integration of ds. ds is the curved area, which is 2 pi r, or we can say this is E into s. S is the curved area, which is E into 2 pi capital R into L. Now if you simplify this, then you will get the electric field. Actually, if you are calculating at that distance, then this point should be at the surface of this cylinder. If you are calculating here, then this point should be here. So for this point we can calculate, it will be E upon L will be cancelled out, then this will be lambda upon 2 pi epsilon naught into R, which can be written like this, 2k lambda upon R. So at the surface of this cylinder it will be 2k lambda upon R. For every point we can make another cylindrical surface and we can calculate the electric field. So it is the real use of the Gauss law. Now इलेक्ट्रोस्टैटिक्स चैप्टर आपका कंप्लीट हो चुका है एंड नेक्स्ट चैप्टर हम देखेंगे करंट इलेक्ट्रिसिटी के बारे में.